Welcome to Computer Architecture Lab. I'm Nachum Danzig, and I'm going to explain Lab Set 3, Question 2. Here you are asked to detect progressions. There are two kinds of progressions. There's a arithmetic progression, which is like 2, 4, 6, 8, each time the number goes up by 2. Also, we have progressions in reverse order. 8, 6, sorry. First one was 2, 4, 6, 8. Now we could do it also negative, where each time the number changes by -2. So it could be 8, 6, 4, 2. Or it could also be 9, 6, 3, 0. Those are arithmetic progressions. Those are geometric progressions where they go up by a power of 2. For example, 2, or by a power. In other words, we multiply it by the same number all the time. For example, 2 times 2 is 4. So 2, 4, 8, 16, 32, 64. But it could also be 3. So it could be 3 times 3 is 9, times 3 is 27, times 3 is 81, etc. But it could also be, for example, 5 times 3. So it would be 5 times 3 is 15. Then times 3 is 45. Then times 3 is 135. That's also, each time it's multiplied by 3, that's also a geometric progression. So if it's multiplied by by a constant number, it's a geometric regression. If you add by a constant number, it's an arithmetic regression. So you're asked to create a numeric list where each number is 1 byte, not word, which means the maximum value is going to be 128 or 27, 127. The address of the list should be stored in A0. Its length should be stored in A1. And you could have positive and negative numbers, which, by the way, I could multiply a number by -3. It shouldn't affect your program, but I could be 3, -9, 27, -120, -81. That's also a geometric regression. Write a program that scans the data list and checks whether the data is an arithmetic regression or a geometric regression or both. It could be both. For example, 1, 1, 1, 1 is both geometric and arithmetic because I'm adding 0 to it each time and also multiplying by 1 each time. Or the other possibility is that it's not any kind of progression. 17, 12, 43 is not a progression. This program should also print a message about the scan conclusion. In other words, it should say what the initial value is and what the D is. The D is the difference if it's an arithmetic, like if I'm adding 2 each time, like 2, 4, 6, 8, then the D would be 2. Or Q if it's a geometric, the quotient. So it would be like if it's 3, 9, 27, 81, the quotient would be 3. And the first number would be 3. Of course, the quotient and the first number don't have to be the same. But there are certain, so for example, what about this progression? 2 times 2 is 4, times 2 is 8, but I write 9. Is that a geometric progression? Well, no, obviously. But your program might think it is, because if it divides, how you can do this, you might divide 9 by 2 and get 4. Because remember, the remainder is ignored. In other words, if I do division, I'm not going to have a decimal number. I'm going to have a whole integer number if I do integer division. So 9 divided by 2 is going to give me 4. So I'm going to take the 9 divided by 2 and get 4. Take the 4 divided by 2 and get 2. So it looks, I might think that I got the right numbers, so it's a geometric progression. So you're going to have to deal with that. In other words, I don't want you to tell me that this is a geometric progression. It's not. That is not a geometric progression. Now, how are you going to deal with that? There's a couple different ways, 2 different ways that I can think of. One way is by checking the remainder. So let's remind ourselves. If you look in the booklet of the commands, which I provided a link to in Moodle, there's a command called div, and what div does is it divides 2 registers and puts the result of the division in the low register, Remember we talked about when we multiply, there's a low and there's a high. So the result will be on the low register. But it'll also put the remainder in the high register. So you could simply check the remainder there in the high register and make sure it's correct. I don't want to say what it should be, but it should be obvious, but you should figure that out. So that's one way to check it. There is another way if you think of it, but basically that is not a progression. What about this though? 16, 20, and 25. Is that a progression? You might say, well, certainly not an arithmetic progression because I added 4, now I added 5. Is it a geometric progression? Doesn't look like one, but actually it is. Because if I multiply 16 by 1.25, by 1 1/4, I will get 20. And if I multiply 20 by 1 1/4, I will get 25. So that is a geometric progression. Do you have to detect it in your program? No. In other words, the Q in this case, Q is equal to 1.25. You don't have to look for geometric progressions where the Q is not a whole number. In other words, the Q has to be a whole number. So therefore, this, even though that is a geometric progression, if you tell me it's not, that's fine. I do not expect you to look for geometric progressions with fractional differences. Okay, so those are the requirements. How are we going to do this lab? So we open up our page, and the first thing we need to do is to write an array of numbers. So for example, data, and let's call it list, and it's of type byte. It said in the question that it was bytes, and I remember that. So I'm going to write byte, and I'm going to put my numbers here. So for example, I could put 2 times -2 is, let's say, -4, times -2 is 8, times -2 is -16, and I have my geometric progression. Now, when I check, obviously, I can change this list. When I run it again, I can put 17 and make sure that now it says it's not a geometric progression. I can alter that for different runs of the program. Now I'm going to write my text. And the first thing I'm going to do is my LA to get the address. LA, doesn't matter which register we use. Oh, it did actually. It said in the question, I believe, which register. It said that A0 is the pointer and A1 is its length. So remember, we have to have its length because otherwise we won't know when to stop and we'll hit zeros after this. So into A0, we're going to put whatever the address of list is, which is going to be, of course, 10,010,000. And now we have the address of the first element. And what are we going to do?
I'm going to go inside here for a second.
Snoopy. Okay. So back to where we were. 3, 2, 1. Yeah. So the simplest way to determine if this is a progression is let's see what the difference is between them. Well, the difference between them is subtraction. We're going to subtract. Usually, it doesn't really matter, but the second number from the first number. So let's say sub, and it takes 3 registers. So into $T0, let us put the difference between, but we need to get those two numbers. So we need to do 2 loads. Which load are we going to do? Are we going to do load word or load byte? Well, this is a byte, so we're going to do load byte. Load byte of into $T1. Let's do load byte of $A0. Now we got the first one, and now we'll do again load byte, into $T2. Now, what number should we write here before the parentheses? We're going to write, obviously, $A0, but what number are we going to write over here? Well, if it would be words, we'd write 4, because that would be the next 4 bytes later, would be the next number. But this is bytes, so it's actually only 1 byte later. So now we have the first 2 numbers. So we're going to subtract, well, what's the order? Well, it doesn't really matter, but let's say the second number, which is $T2, $T1, and we're going to get some kind of difference. Now, we don't know how many numbers are here. It could go on much longer. We do have its size. Oh, we didn't put its size. We need to put its size, so let's do that. LI $A1 equals 4. That was what was written we're supposed to do. This is pseudo, these 2 commands, but those are the 2 commands you're allowed to use, and you're allowed to use them only in these 2 ways. Okay, so now we've got the first 2 numbers. We got the first difference. And we've stored it in. Now we need to start a loop, because we need to check, is that difference the same as the difference over here and the difference over here? So let's write like loop, and or let's call it arithmetic loop, because we're going to have another one for geometric. And well, we need a count. We need a counter. Now, if we destroy this 4, if we decrement this 4 every time, then we're not going to have the 4 again for the next time we do the loop when we do geometric. So we're going to have another. Let's count up to that. So let's say like this. Well, let's say as long as, let's take another variable. Let's say if branch equal, or if it's equal to the size, which is $A1, if our counter, let's call our counter $S1, is equal to that, then let's go to let's call it end arithmetic. If A1 is equal to S1. Now S1, we've already got the first 2. So we're going to do how many more checks? We're going to do 1, 2 more checks. So we're going to have to, we've already done 2, so let's start off $S1 with the value 2. So we've set S1 to 2 because we've already checked our first 2 and before we started our loop. Now, since we're checking for a series, it's safe to say that there are 2 elements at least, because we can't have a series without at least 3 elements. So it's a valid assumption to assume that there are the first 2 there. Normally we'd have to check if there's just 1 and end perhaps after the first one. But we know that it's got to be at least 3. So we'll set it to 2, which means that we've checked the first 2. And now we're going to check, is S2 equal to the size of our array? No, probably. So we can continue. And we're going to do a increment of our pointer. And so we can compare the next 2. So we're going to do something like add I $A0. Now you may be worried, wait a second, we're going to lose the pointer. No trouble, we could just do another LA on list later on when we want to check if it's geometric. So $A0 plus the value, well, it's a byte list, so it's just going to be 1. And now we can check the next two elements. And we're going to copy these lines. We may have to alter them. We're going to check if the difference, again, is the same, but we have to store the original difference that we got here. We stored it in T0. Fine, so that's good. So we can leave these two the same. And now we're going to have a T3. We're going to have to copy this line. May not be the most efficient code, but it will work. You have to copy this line into another variable, T3. And now comes the main point. We have to compare T3 with T0. BNE $T3 $T0. They're not equal, go to make a place called not arithmetic. And now in that place, not arithmetic, we're going to obviously print out that it's not arithmetic. And then we're going to continue on and do the check for geometric. But if it was equal, then we have to check if we're finished. So we have to do add I, S1. That's our counter, right? $S1, $S1 plus 1. And then we have to do jump to arithmetic, probably with an E, I don't know. Arithmetic loop. So we'll keep on going till eventually we either get a break or we get, if we break early, that meant it was not arithmetic. But if we got all the way to the end and we broke here because we just reached the end of our counter and every time we checked it, everything was fine, that means that end arithmetic means it is arithmetic. So not arithmetic, we're going to have to print out some kind of message, print not arithmetic, and then we're going to have to do some kind of jump to geometric. Geometric. And now here will be end arithmetic, and this means we got there and we never found a problem. So that means we're going to print out something like print is I think it's with an E, but anyway, arithmetic. Okay, and now we're going to do geometric here. Here we don't have to, we're going to do geometric. So let's do geometric colon. Love what we got to do with a capital because I did it with a capital there. So geometric. And here we're going to do the same kind of thing, but we're not going to do subtraction to see the difference. We're going to do division. Division is again, just use this div. Do not use any other div. See these 3 divs that it shows me here, or 4? just use the first one, which means div two numbers. Well, we're going to have to, again, get those two numbers. We're going to have to, again, get our pointer. So we're going to have to do something like, let's go back up here, and let's go back up here, and up here, and all these lines we're going to copy again because we're doing a whole new loop. Control C, and down here, and we're going to do V, and again we got our list, again we got our size, and we got our first two elements, and we're going to do something like this: div $T1 $T2. And that is going to give us the difference between them. But is it, wait, which one to which? Should be the second one to the first one. So it should be T2. Maybe I had the order wrong before also. You'll have to fix all those little errors if there are. Subtraction should be the second one. Yeah, it should have been the second one minus the first one, really. So here should also be the second one divided by the first one. And where's the result going to go? So it's going to go to the low and the high. Remember over here we have a low and a high. So we have moved from low into some register. $T3. Remember, we're essentially starting a whole new program. We've already finished with that, and we're just starting off again. And that'll give us the low. What is in the high? When I do division, I divide two numbers. The low is the result of the division. The high is empty. So let's use the high. So the computer puts automatically whatever remainder of the integer division it puts into the high, and that might be very useful for us in our check for geometric progressions. Okay, I'm going to stop here. I hope this helped you, and good luck.